Introduction to Robotics, Part 2 of 2. Robots in Education. Today, more than ever, schools are adopting robotics in the classroom to revitalize curriculum and meet ever-increasing academic standards required for students. Robotics not only has a unique and broad appeal. Why is robotics important? Robotics is an emerging field with applications in many facets of our lives. VEX Robotics Design Systems. Beyond science and engineering principles, a VEX Robotics project encourages teamwork, leadership, and problem-solving among groups. VEX Product Subsystems. The structure, which is all metal, fasteners, and structural mechanical plastic VEX parts. Motion, which includes motors, servos, gears, chains, and sprockets, tank treads, and associated items. Power, like batteries, chargers, and associated items. Sensors, bumper and limit switch, ultrasonic, line follower, shaft encoders, and potentiometer. Logic, the microcontroller, PWM cables, and programming kits. And control, joystick, transmitter, receiver, crystals, signal splitter, and tether cables. Structure subsystem. These parts are the skeleton of the robot to which all other parts are attached. This subsystem consists of all the metal and components and hardware pieces. These pieces connect together to form the skeleton or frame of the robot. In the VEX Robotics Design System, the majority of the components in the structure subsystem are made from bent aluminum or steel sheet metal. VEX square holes are also used in alignment features on some components. These pieces will snap into place in these square holes. When using screws to attach things together, there are 3 different nuts which can be used. Please sketch the pictures on the following 3 slides into your engineering notebook. Nylock nuts. Nylock nuts have a plastic insert which will prevent the screw from loosening. These nuts are harder to install, and open-ended wrench is needed to tighten them. However, these nuts will not shake loose due to vibration or movement. Keps nuts. Keps nuts have a ring of teeth on one side of them which will grip the piece they are being installed on. An open-ended wrench is not needed to tighten them, but it is recommended. These nuts are installed with teeth facing the structure. They can loosen up over time if not properly tightened, but they work well in most applications. Regular nuts. Regular nuts have no locking feature. These basic hex nuts require a wrench to install and may loosen over time, especially as a result of vibration or movement. They are thin and can be used in certain applications where nylock or Keps nuts would not fit. Structural subsystem standoffs. Another useful structural component are the 8 32-threaded standoffs. These standoffs come in a variety of lengths and add a great deal of versatility to the VEX kit. Standoffs are useful for mounting components as well as creating structural beams of great strength. Motion subsystem. The motion subsystem comprises all the components of the VEX Robotics Design System which makes a robot move. The motion subsystem is tightly integrated with all the components of the structure subsystem in almost all robot designs. The most fundamental concept of the motion subsystem is the use of a square shaft. Most of the VEX motion components use a square hold in the hub which fits tightly on the square VEX shafts. Sketch the following picture in your engineering notebook. Motion subsystem. The motion subsystem also contains parts designed to keep pieces positioned on a VEX shaft. These pieces include washers, spacers, and shaft collars. Power subsystem. Power is vital to the operation of all the electronic parts of the robot, including the controller and the motors. Sensor subsystem. The sensor subsystem gives the robot the ability to detect various things in its environment. Sensors can enable the robot to function independently of human control. A sensor will generally tell the robot about one very simple thing in the robot's environment, and the robot's program will interpret that feedback to determine how it should react. Logic subsystem. The logic subsystem major component is one of the VEX microcontrollers. A microcontroller is the most integral component of the entire VEX system because it coordinates and controls all of the other components. The VEX Cortex microcontroller comes pre-programmed with the default routine which allows users to get their robots up and running as quickly as possible. Control subsystem. The control subsystem enables a human operator to maneuver the robot. Commands are issued through joysticks and buttons on the VEXNet joystick and sent wirelessly to the robot. The VexNet joystick allows a human operator to control a robot in real time using the innovative VexNet wireless link. Answer the following questions in your engineering notebook. How do robots benefit society? Explain how the different subsystems work together. And how does the installation of sensors improve the functioning of the robot?